Hi students, welcome back to the course on design of machine elements, and in today's lecture we will discuss about riveted joints. So let's start rivet joints. So this figure shows the rivet and the process of making a rivet to riveted joint. Okay, so let me just explain you this process. Figure A shows the rivet, which consists of a cylindrical shank and a head at one end, and this head is formed by an offsetting process in a machine which is called as an automatic header. Okay, so now suppose we are going to join these two plates, plate number 1 and plate number 2. So how we will join these two plates with the help of rivet, that I am explaining you. So we will place this rivet in the common hole of these two plates, and we are providing a backup bar to the head of this rivet, and this portion which you are seeing, the extruded portion above the plate surface, is called as protruding end of the rivet. Protruding end of the rivet. And now we will make this protruding end just like the closing head. How? We will apply a force on this protruding end either by hand riveting or by machine riveting. Okay, and this protruding end will take the shape of the die after that. Okay, and finally it will become a riveted joint, as you can see here. So this closing head, this is the now closing head of the rivet, and in rivet terminology this closing head is called as point. Okay, so this is the process how a rivet will become a riveted joint. So I hope it is clear. Now a rivet is specified by the shank diameter. Okay, so suppose for example I'm saying that a 20 mm rivet, it means a rivet is having a 20 mm as its shank diameter, which is also called as nominal diameter. The standard sizes of the rivets are 12, 14, 16, 18 and so on. And standard sizes, as you know, are those sizes if we are going to the market and we are purchasing rivets. So only these standard values will be available in the shop, not in between these values. And this final figure shows the actual rivets, how rivets looks like. Okay. So next we have types of riveted joints. Types of riveted joints, just like welded joints, we had two types of joints, which the first one was fillet, or which is also called as your lap joint, and second one was your butt joint. So similarly, we will classify the riveted joints. First we have a lap joint. This is your lap joint, and as you know, lap joint is that joint, means it consists of overlapping of the plates, and we are joining these two plates with the help of the rivets, and the number of rows of the rivets may be 1, 2 or 3. As you can see in the figure A, B and C. In figure A we have only one row, in figure 2 we have 2 rows, and similarly in figure C we also have 3 rows. So depending upon the number of rows, now we can classify lap joint as single riveted lap joint, and if we have 2 rows then we can classify it as double riveted lap joint. Okay, so B and C we can call it as double riveted lap joint. I hope it is clear. And figure A is the single riveted lap joint. Why lap joint? Because the plates are overlapping on each other. Now, one more thing I would like to mention over here, that see, in figure B and C, when we have 2 rows, that is double riveted lap joint or in triple riveted lap joint. See the arrangement of the rivets. The rivets are placed in a particular order. So B, the B figure shows a chain type riveting. Okay, the chain type riveting is that type of riveting where the number of rows are placed in such a way that one row is exactly placed opposite to each other. Okay, and figure C shows your zigzag pattern. Okay, in zigzag pattern, the rivet is placed in between the center of the 2 rivets of the adjacent row. Okay, so B figure we can say it is a chain type riveting. Chain type riveting. And figure C shows your zigzag riveting. Okay, what is the difference between them? I explained you that the rivets are placed in such a way that in chain type riveting, the rivets are placed that each row is opposite to each other, and in zigzag, the rivet is placed in between the center of the two rivets of the adjacent row. I hope it is clear. Okay. So now let us discuss second type of riveted joint that we have. This is your butt joint. Okay. And butt joint, as now you are familiar with the butt joint. Butt joint is that joint where we are going to join two plates whose planes are lying approximately in the same plane. Okay. Then that type of joint is called as your butt joint. So this figure shows that we have two types of plates, plate A and plate B, and we are joining these two plates and we are providing a strap on them. Now, if we have a single strap in this figure, you can see we have a single strap, and in this figure we have two straps, strap 1 and strap 2. So based upon the number of straps, we can now classify our butt joint as a single strap butt joint and double strap butt joint. Okay, so ये ऊपर वाला figure बन गया single strap butt joint. And this one is a double strap butt joint. Okay, so let's move ahead. I hope it is clear now. Classification of riveted joints. We have two types of riveted joints, lap joint and butt joint. Okay. Now there are some terms which we will use in our riveted joints. As you can see in this figure, we have small p, which is called as pitch. Small d is the strength diameter. And we have M is called as margin. PT is your transverse pitch, and PD is your diagonal pitch. Let me discuss all these terms one by one. Let's start with pitch. So pitch of the rivet is defined as the distance between the center of one rivet to the center of the adjacent rivet in the same row. If in a same row we are finding out the distance between the two rivets, that is called as your pitch. Okay, as you can see in this figure, A, B and C. सेम रो में अगर आप दो रिवेट्स के सेंटर का डिस्टेंस फाइंड आउट करना चाहते हो, उस डिस्टेंस को बोलेंगे पिच. नाउ पिच इज 3 times of diameter of shank diameter. This is the standard value. Okay. Now margin. Margin is the distance between the edge of the plate to the center line of the rivet in the nearest row. Okay, so it is the distance between the center of the rivet to the nearest edge from the center of the rivet. So आप ये भी कह सकते हो कि सर there are two edges here. दो प्लेट्स हैं, दो एजेस हैं, वन एज इज दिस एंड अनदर एज इज दिस, बट आपको वो एज लेना है जो नियरेस्ट होगा सेंटर ऑफ रिवेट के. ओके, सो दिस इज योर मार्जिन, एंड मार्जिन इज 1.5 times of diameter of shank. Okay, I hope it is clear. Third term is transverse pitch. So transverse pitch is also called as your back pitch or row pitch, and it is the distance between the two consecutive rows of the rivets in the same plate. Same plate में if you are finding out the distance between the two rows, so two rows, that is double riveted lap joint हमने बात करी थी. Now how one row is placed from the first row at a what distance, that particular distance is called as your transverse pitch. Okay, now this figure shows your transverse pitch. So दोनों rows के center distance को आप pitch transverse pitch बोलते हो. Now the value of the transverse pitch for chain riveting is 0.8 p, and for zigzag it is 0.6 p. Okay, remember this thing. The last term is your diagonal pitch, and diagonal pitch is the distance between the center of one rivet to the center of the adjacent rivet located in the adjacent row. And diagonal pitch, keep this in mind, this term will be used in zigzag pattern only in zigzag pattern. The diagonal distance between the center of two rivets is called as your diagonal pitch. Okay, so these are the terminologies or the terms that we generally used in our riveted joints. So next is strength equations of riveted joints. Just like we had developed the strength equations in our welded joints, and after that we have solved the questions in a similar fashion, now we are going to derive strength equations for riveted joints. And after getting the fundamental knowledge about the strength equations, it will be easy for us to solve the numerical problems. So what is a strength? As you know, what is strength? Strength of the riveted joint is defined as the force that the joint can withstand. So keep this in mind, that strength is what? The force. Whatever the force that we are applying on any joint, if that joint is withstanding that particular force, that is called as the strength of that particular joint. If any joint is not withstanding that particular force, so the joint is definitely going to fail. तो basically strength क्या होता है, वो force होता है basically जो हम किसी joint के ऊपर लगाते हैं, और अगर joint ना टूटे वही उसकी strength कहलाती है. So in strength equations, what we are going to derive, we are going to derive the force, the value of force. Okay, so in general mainly there are three types of failures which are considered in rivets. Those are shear failure of rivet, this is first type. Second is tensile failure of the plate between the two rivets, and crushing failure of the plate. Now let me discuss one by one these failures. Let us take first shear strength of the rivet. Now suppose we are applying a tensile force on the plates and the rivets are going to fail by shear. So how we will calculate the shear strength of the rivet? So this is the rivet and these are the two plates, and this is the shearing which is going to take place. So now the shear stress will become, that is shear force, that the tensile force that we are applying, PS as for shear, divided by area of the rivet, and area of the rivet will be pi by 4 d square. And from here we are interested to find out PS, and it will become pi by 4 d square into tau. ओके, ये आप देख सकते हो सेम फार्मूला यहाँ पे आपके पास लिखा हुआ है. तो ये किस तरह से है मैंने आपको बता दिया, दैट द shear strength of the rivet will be this one, and where all these terms, d, small d shank diameter, tau is the permissible shear stress in Newton per mm square. And in case of double or triple riveted lap joint, this equation will be modified by multiplying with n. So for double riveted lap joint, you will have to multiply with 2. For triple riveted lap joint, multiply with 3. Okay, so the formula will be changed accordingly. Okay, now in case of double shear, suppose in case of butt joint, so this particular figure shows your butt joint and there are two straps, strap 1 and strap 2. So this joint will be called as double strap butt joint. So in double strap butt joint, as you can clearly see over here, that there are two, that the shear is double shearing. So in case of double shearing, what will become pi by 4 d square into tau into n, where n is the number of rivets in a plate. The rivets may be 3, 4, 5, 6, 7, 8, whatever be the number of rivets that you will have to multiply here. Now this is for single shear, but in case of double shear, just like in double strap butt joint, you will have to multiply with 2. Okay, for double shear. So formula will remain the same, only change is that in double shear multiply with 2. So this is your first failure. This was your first failure. Now let us discuss the second type of failure, or strength equation for tensile strength of the plate between the rivets. Now see, this figure shows two rivets A and B. Now we are going to find out the tensile strength of the plate between the rivets. So first of all, identify which type of force is acting on the plate. Tensile force is acting on the plate, and the plates are going to fail in tensile stress. So the failure will be tensile stress failure. So find out the value of the tensile stress, that is sigma t. Sigma t will be equal to pt, that is force, divided by area between the two rivets. Area between the two rivets. So first of all, find out the length. Length and thickness will become the area, and so this will be the length between the two rivets. Okay, and how much value is this? Total value is p. Center to center distance between the two rivets is called as your pitch. I explained you just in the previous slide. So from center to this particular region, the value is half of diameter of the rivet. So it will become d by 2. So d by 2 and d by 2. So d by 2 plus d by 2, it will become d. So p minus d, this particular region will become p minus d, the length. And if you multiply this length with thickness of the plate, because this plate की कोई ना कोई thickness भी होगी, if you multiply with the thickness of the plate, then it will become the area. So sigma t now will become pt divided by p minus d into t. And we are interested to find out the tensile strength of the plate, that is pt, and it will be p minus d into t into sigma t. ठीक है, so इस तरह से फार्मूला आप डिराइव कर सकते हो, और ये फार्मूला हम यूज करेंगे अपने न्यूमेरिकल्स में. सो देखिए, सेम फॉर्मूला यहाँ पे लिखा हुआ है, आया किस तरह से मैंने एक्सप्लेन कर दिया आपको. ओके, एंड let us now discuss the third type of failure, which is the crushing strength of the plate. If the plate is going to crush, so देखिए प्लेट के बीच में हमने क्या प्लेस कर रखा है, हमने प्लेस कर रखा है रिवेट को. अब रिवेट में अगर क्रशिंग हो रहा है, बेसिकली क्रश, तो रिवेट का डायमीटर जो होगा और थिकनेस ऑफ जो प्लेट होगी वो आपका क्या होगा, एरिया क्रश होगा. सो डायमीटर ऑफ द रिवेट इनटू थिकनेस ऑफ द प्लेट will be the area under crushing. Remember this thing. Okay, so area under crushing, if we find out area under crushing, it will be diameter of the rivet into thickness of the plate. And what will be your sigma c now? Sigma c, that is the crushing stress, will be pc divided by d into t. Or from here the crushing strength will become, because we are calculating crushing strength of the plate, so crushing strength will become d into t into sigma c. This will be the formula. And if there are number of rivets, so multiply with n in this formula. Okay, ये देखिए, this is the formula. PC will be equal to d into t into sigma c into n. N is the number of rivets. Okay, n is the number of rivets. So I hope all these three all these three strengths are now clear to you. As you know, we have derived three strengths. First was shearing strength, second one was tensile strength of the plate between the rivets, and third one was crushing strength of the plate. Okay. So next we have efficiency of joint. Efficiency of riveted joint is defined as the ratio of the strength of the riveted joint to the strength of the unriveted solid plate. So this is how we will find out the efficiency of the riveted joint. So the formula for efficiency is that lowest value of PS, PT, and PC. As you know, after making the riveted joint, we have to calculate the strength of that riveted joint, and we have three strength equations. Okay, and out of those three strength equations, whichever is the lowest value, take that value and divide that value with strength of solid plate, that is not riveted, that is unriveted solid plate. And how you will calculate the strength of the unriveted solid plate? Strength means force, and that force will be equal to stress, that is sigma t. The force that we are applying on the plate is sigma t, is basically tensile force. So the force will become, that is P, stress into area. So that will be your width into thickness will be the area into your stress. This will be your tensile force, or you can say the strength of the unriveted solid plate. Okay, and you can replace this width with the pitch also. So this will be the formula. And after that, we have caulking and fullering. So caulking and fullering are the two processes in the riveted joints that are used to make leak-proof joint, or you can say airtight joints or fluid-tight joints. So caulking and fullering both are the same processes, and the only difference is of the tool. This is the caulking tool and this is the fullering tool. In both the processes, we are applying the hammer. We are applying the hammering force with the help of a hammer, and we are closing the voids that are open in the riveted joints. And utmost care has to be taken care here, because if we are hitting the voids that are opened, and in spite of closing them, sometimes it may happen that you are opening the voids more. Okay, so utmost care has to be taken in order to close these voids. Okay, so fullering, as it is written over here, it is similar to the caulking process except for the shape of the tool. So caulking and fullering are the processes which are used to make the leak-proof joints or fluid-tight joints. Now let us solve some numerical problems on the riveted joints. This is your example 8.81. It says a brake band attached to the hinge by means of a riveted joint as shown in the figure. This is the figure which shows your brake band attached to the hinge. So this is your brake band. This is the side view and this is the top view, And from the top view, we can see the width of the band, that is W is the width of the band. And determine the size of the rivet. And you can see there are 4 rivets in this particular joint, and we have to find out the size of the rivets. It means first we have to calculate the diameter of the rivet. What will be the diameter of the rivet, that we have to find out. Also determine the width of the band. Second, we have to find out the width. And the permissible stresses for the band and the rivets in tension, shear and compression are 80, 60 and 120 Newton per mm square. So all the permissible stresses are known to us. Assume margin as 1.5D, transverse pitch as P, and find the pitch of the rivet. So third term that we have to calculate here is pitch. So we have to find out diameter of the rivet, width of the band, break band, and pitch between the 2 rivets. Okay, so let us try to solve this question. So let me provide you the solution now, how we will solve this question. First of all, you can say the given conditions that we have a tensile force which is given to us 10 kilonewton, which we can say 10,000 Newton. Convert all the units in Newton mm. Okay, after that we have P. After P we have all the permissible stresses. Sigma T will be equal to 80 Newton per mm square. Then we have permissible shear stress, tau, will be equal to 60 Newton per mm square. Then we have compressive stress, permissible compressive stress as 120 Newton per mm square. Apart from that, thickness of the plate is also given to us. This is your plate and thickness of the plate. Okay, this is the plate. ये आपको plate दिखा रहा है यहाँ पे. Okay, so thickness of plate is 3 mm. These are the given conditions that we have. Now let us try to find out the first diameter of rivet. Very small d. So how many rivets are there? First of all, you need to find out there are 4 rivets. 1, 2, 3 and 4, and they are subjected to shingle shear here and here. So shear stress will become force divided by area of the 4 rivets. And it will become tau will be equal to force divided by 4 into pi by 4 ऊपर ले गया मैं into d square. और हमें d निकालना है यहाँ से. From here d square will be equal to, that is p into 4 divided by 4 pi into tau. So we have all the terms, we have the given values of all these values. Capital P, that is the tensile force, that is 10 kilonewton. So 10,000 Newton multiplied by 4 divided by 4 pi into permissible shear stress tau, which will be 60. Okay, so from here you will get the value of d as under root of this value, and after solving this you will get 7.28, approximately equal to, it is coming 8 mm. Okay. And apart from that, you can also check the diameter of the rivet, or you can also find out the diameter of the rivet from crushing criteria. That suppose if the rivet is going to fail by crushing stress. So from crushing consideration, you can say from crushing consideration, your diameter of rivet, crushing stress will be force divided by area of 4 rivets. So 4 rivets, area will become d into t, as I explained you earlier. So from here your d will become, d को इस तरफ ले आइए, p divided by 4 into t into sigma c. So from here your d will become 10,000 Newton divided by 4 into thickness of plate is 3 mm into sigma c is 120 Newton per mm square. So after solving this, you are getting your value as 6.94. Okay, approximately equal to 7 mm. So out of these two values, consider that value which is maximum. So 8 mm is the maximum value, so it will become the design criteria. Okay, so हम जो diameter लेके चलेंगे वो 8 mm लेके चलेंगे अब यहाँ पे. So first हमारा जो है वो 8 mm आंसर आ चुका है. Second width of band निकालिए अब आप, ठीक है ना. Width of band ये निकाल दिया हमने. सेकंड जो हमें निकालना है वो width of band निकालना है. That is W. So now width, in order to find out the width of the band, as you know that we have a tensile force which is acting here on the break band, on the plate, and which failure is going to occur here? Tensile failure. So sigma T from here will become force divided by area under failure. It will be, अगर इसमें प्लेट में फेलियर होता है मान लो आपका, और इसमें बैंड में अगर फेलियर होता है तो क्या होगा, ये यहाँ से टूट सकता है x along x section. So there are two holes. You need to subtract these two diameters from the width, so it will become W minus 2D. Okay, अगर solid plate होती तो W आता, W into T, that will be the area. But यहाँ पे दो रिवेट हैं तो आपको वो दो रिवेट माइनस करना पड़ेगा. एरिया along x, W minus 2D into thickness of the plate, है ना, thickness of the plate. Okay, so now from here your P will become, that is sigma T into W minus 2D into T. ठीक है, यहाँ से अब आप P हमारे पास है 10,000 न्यूटन, which will be equal to sigma T is given 80 Newton per mm square into W minus 2 into D. D is 8, 16 mm आ गया, into thickness is 3 mm. So देखिए इस equation there is only one unknown now, which is W. So width from here, when you will solve this equation, you will get the value of W, that is width of the band, as 57.67. Okay, and approximately equal to, it will be your, let us say 58 mm. And in our textbook that this value round इन्होंने किया है 60 mm. ठीक है ना, तो you can round it as 58 mm also. Both are correct. Okay, in our textbook they are taking the standard values. So after getting the width, now we have to find out pitch. उससे पहले margin निकाल लीजिए आप, ठीक है ना. Margin from here, that is 1.5 times of D, and when you will solve this 1.5 into 8, it will be your 12 mm. And after that PT will be equal to P, transverse pitch will be equal to P. So P निकालना है हमने, और P निकालने के लिए you know जो width है वो किसके बराबर है, ये width को हम लिख सकते हैं, that is M plus P plus M. So we can say this width will be equal to M plus P plus M, ठीक है ना. और इसको ऐसे भी लिख सकते हैं, width will be equal to 2M plus P. From here your pitch will be W minus 2M, W minus 2M. इसको further solve कर लीजिए. Your pitch will be, width is coming 58 minus 2 into M, that is 12 margin. Okay, this margin is coming 12 mm. So from here now your pitch is coming 58 minus 24. Okay, 58 minus 24, and this value will be 3 and 4, 34 mm. So ये आंसर आ गया आपका पिच का, ठीक है ना. पिच आ गया हमारे पास. विड्थ ऑफ बैंड हमने निकाल दिया था, दिस विल बी योर आंसर, ठीक है ना. और डायमीटर हमारे पास 8 mm आ गया था. तो ये तीन चीजें निकालनी थी आपको इस क्वेश्चन में, और तीनों हमने निकाल दी. आई होप दिस क्वेश्चन इज क्लियर टू यू नाउ. लेट अस मूव अहेड ऑन द second question. So this is the example 8.19. It says two flat plates subjected to a tensile force P are connected together by means of double strap butt joint. Now here we have a butt joint which consists of double strap. सी, ये प्लेट 1 होगी, ये प्लेट दूसरी होगी, ठीक है ना. This is your strap 1, strap 2. That's why it is called as double strap butt joint. Okay, so these two plates are connected together and the force P is 250 kilonewton. So let me write given conditions. P is given to us 250 kilonewton, which will be equal to 250,000 Newton. Okay, and after that, the width of the plate W is 200 mm. Here, width is given to us 200 mm. Okay, and the rivet and the plates are made of same steel, and the permissible stresses in tension, compression, and shear. Once again, the permissible stresses are given to us. You can write the values of these permissible stresses as sigma T 70 Newton per mm square. Then we have compression, permissible compressive stress as 100, and permissible shear stress as 60 Newton per mm square. Determine the diameter of the rivet. Okay, D निकालना है आपको. Thickness of the plate T निकालना है हमें. Thickness इसमें given नहीं, पिछले वाले क्वेश्चन में given था आपको. Dimensions of the seam P, PT, that is pitch, transverse pitch और margin. यहाँ पे निकालना पड़ेगा. Efficiency of the joint, that is efficiency निकालना है आपको. So इस क्वेश्चन में हमसे काफी कुछ पूछ लिया गया है. So it is an important question. देखिए इसको कैसे सॉल्व करेंगे. Let us try to find out the diameter of the rivet. First, so since it is a double strap, so there will be a double shear, okay, at this particular point and at this particular point. So we will consider only the one plate, और उसी one plate के रिस्पेक्ट में हम क्या करेंगे, अपना एनालिसिस करेंगे. और एक प्लेट में कितने नंबर ऑफ रिवेट्स हैं? ये प्लेट 1 हो गया, ये प्लेट दूसरी होगी. दोनों प्लेट को मैंने बट ज्वाइंट कर रखा है, और एक प्लेट में देयर आर 5 रिवेट्स. 1 2 3 4 and 5. There are total 5 number of rivets which are in double shear. So formula आपको पता ही है. We know that the shear strength for double shear will be twice, ठीक है ना, and it will be pi by 4 d square into tau into n, ठीक है ना. ये फॉर्मूला हमने ऑलरेडी डिराइव करा था shear strength वाला. डायरेक्टली इसी फॉर्मूला का यूज कर सकते हैं हम लोग. एंड PS will be twice because it is a double, for double shear formula ये यूज करेंगे हम लोग. और यहाँ से PS, that is the force which is acting here, वो shear strength हो गया, वो given है हमारे पास, that is 250,000 will be equal to 2 pi by 4 d square, d निकालना है हमने, into permissible shear stress tau is 60 Newton per mm square into number of rivets are 5. So in this equation now we have only one unknown which is d, and you will easily find out d from here. The value of d is coming 23.03. okay, and approximately इसको आप 24 भी कर सकते हो, no issue, but अभी मैं जो टेक्स्ट बुक में स्टैंडर्ड वैल्यू ली है उसको ले रहा हूँ. स्टैंडर्ड वैल्यू यहाँ पे ली है 25 mm, ठीक है. तो ये हमारे पास आ गया डायमीटर ऑफ रिवेट. इतना होना चाहिए डायमीटर ऑफ रिवेट इन ऑर्डर टू विथस्टैंड force of 250 kilonewton. Let us now try to find out the thickness of the plate. Okay, second point. Thickness of plate. So a tensile force is acting on the plate. Tensile failure is going to occur definitely. The question arises, so from which section the plate is going to fail. So now as our fundamental knowledge, you can say that sir, along the minimum area of cross section our plates are going to fail. So this along x-axis section the plate is going to fail. And the next thought which will come in our mind is that कि अगर ये 3 रिबेट्स अगर फेल होते हैं तो उससे पहले ये 2 रिबेट फेल हो जाएंगे, ठीक है ना, बिकॉज फोर्स बिल्कुल एज पे फोर्स लग रहा है तो एज पे ज्यादा स्ट्रेस होगा और धीरे धीरे फ्लो करेगी स्ट्रेस. सो अगर ये 3 रिबेट में अगर फेलियर होता है अलॉन्ग एक्स एक्स, उससे पहले इन दोनों में हो जाएगा। ये भी एक थॉट आता है हमारे माइंड में। सो इफ अगर पहले ये फेलियर होता है तो फिर हमें वाई वाई सेक्शन के अलॉन्ग हमें फेलियर लेना पड़ेगा। ओके, सो इन ऑर्डर टू अंडरस्टैंड दिस कॉन्सेप्ट, लेट मी जस्ट make this concept understandable to you with the help of one experiment. Okay, so ये आप देख रहे होंगे, इसमें हम क्या करेंगे कि ये 2 रिवेट है हमारे पास, ये 3 रिवेट हैं, ये भी 3 रिवेट हैं और ये 2 रिवेट हैं। अगर मैं फोर्स लगाता हूँ टेंसाइल फोर्स इसमें, तो देखिए कहाँ से फेल होगा ये। ठीक है, साइड से फेल हो गया, मतलब 2 रिवेट पहले फेल होंगे, उसके बाद ऐसा हो सकता है कि 3 रिवेट फेल ना हो, ऐसा हो सकता है 3 रिवेट फेल ना हो, पर ये 2 रिवेट फेल हो गए। So now the area which you will consider will be along YY section, not along XX section. बस ये चीज आपको ध्यान रखनी है। ओके, सो आप अगर ये समझ आ गया आपको, तो now from here you will get the value of thickness. So tensile stress will become from here, that is force divided by area along YY, and it will be force divided by W. If now along YY section there are 2 rivets, so width minus 2d into thickness of the plate will become the area, and from here your sigma t will be how much? 70 Newton per mm square, which will be equal to 250 kilonewton divided by width. Width is given to us in this question, that is 200 mm. So 200 minus 2 into d, that is 2 into 25, 50 into thickness. So now there is only one unknown in this question now, which is thickness, and after solving this you will get the value of thickness of the plate as 23.81 mm, and approximately equal to the standard value is 25 mm. Okay, in your questions you can also write it as 24 mm. Okay, बार बार रिपीट कर रहा हूं मैं, वो गलत नहीं होगा आपका। So this will be your answer now for second point, that is thickness of plate is 25 mm. And let us move ahead now. Find out the dimensions of the seam, that is pitch, transverse pitch and margin. Okay, so now pitch, if you would like to find out, pitch will be width of the plate divided by width of the plate divided by maximum number of rivets in a row. So maximum number of rivets in a row, basically there are 2 rows here in a single plate, and the pattern is zigzag pattern. So you need to find out this P, and in a row the maximum number of rivets are 3. इसमें 2 हैं, इसमें 3 हैं, तो आपको यहाँ पे pitch निकालना है, that will be width 200 mm divided by 3 number of rivets in a row, maximum number of rivets, or from here you will get your answer as 66.67 and approximately equal to 67 mm. So this will be your pitch, and transverse pitch निकाल दीजिए आप। Transverse pitch निकालने के लिए, you know, this is your zigzag pattern, and for zigzag pattern your value of PT is 0.6 into P, ये मैं आपको बता चुका हूँ। So 0.6 into 67, or when you will do this, your answer will be 40.02, 40.2, let us see. So you can write it as 41 mm. And the last value is margin, and the value of the margin is 1.5d. When I was explaining you the terminology of the riveted joint, so I explained you over there that margin basically hota kya hai? Margin is the distance between the center of the rivet to the nearest edge of the plate, and its value is 1.5 times of diameter of the rivet. So okay, so 1.5 into diameter of rivet is 25, and you will get the value of margin as 37.5, and its value is coming the standard value as 40 mm. Okay, and now ये निकालने के बाद लास्ट पॉइंट हमारे पास है efficiency of the joint. Okay, efficiency of the joint. And you know, efficiency of joint will be lowest value of PS, PT, and PC. Out of these three, divided by strength of unriveted solid plate. ठीक है. So it means now we have to find out PS, PT, and PC. तो वो आप निकाल सकते हो आराम से, because now we have all the values. You need to just find out the values. So PS, as you know, the formula that we have twice of, because it is a double shear, 5/4 d square into tau into n. Okay. अब d आपको जो हमने diameter of rivet निकाला वो पुट करना है आपको, n is the number of rivets, actual diameter पुट करना है आपको यहाँ पे. तो 2 into 5/4 d square, and diameter that we have is how much? 25 into tau will be your 60 into number of rivets are 5. When you will solve this, you are getting the value of PS as 294,524.31 units will be Newton. Similarly, you will find out the value of PT, tensile strength of the plate between the plates. Okay, and the tensile strength will be what will be the formula? W minus 2D into thickness of the plate into sigma T. Okay, and when you will solve this, or we have all the values, W 200 minus 2 into 25 into thickness of the plate. ये हमने निकाल दिया था, thickness of plate, how much? 25. Okay, 25 here. Okay, 25 into sigma T, we have 70 Newton per mm square. और जब इसको आप solve करोगे, your PT is coming to 62,500 Newton. And PC, that is crushing strength of the plate, और वो क्या आएगा? D into T, how many number of rivets are there? 5. 5 into D into T into sigma C. This will be the formula. तो इसमें आपका बन जाएगा 5 into 25 into 25 into 100. Sigma C is 100. जो इसको solve करोगे, it is coming out 312,500 Newton. So out of these three values, now you can see the lowest value is which one? 262,500. This is the lowest value. Okay, this is the lowest value. So now we will take this value, and strength of unriveted solid plate, वो क्या आएगा आपका? Strength of unriveted solid plate will be, that is, P is equal to W into T into sigma T. Okay, and it will be 200 into 25 into 70, and the value is coming 350,000 Newton. Okay, now from this equation, that is efficiency of the joint will be, lowest value out of PS, PT, and PC will be 262,500 divided by 350,000 Newton. And when you will solve this, it is coming out 0.75, और efficiency अगर आपको निकालना है in percentage, so 0.75 multiplied by 100, so it is coming out 75%. Okay, so this will be your answer. And in this way, you can solve the numerical problems based upon the design of riveted joint. Okay, so I hope this whole lecture is clear to you. Watch the whole video carefully, and if you have any doubt, you can ask. Okay, thank you so much.